downhill, okay? But my skiing, it's kind of backwards. My teaching's going downhill, but my skiing's going uphill. Should be the other way around. I do, because I go cross country skiing. All right. Anyway, that was the joke of the day. I know that wasn't very funny. But I'm built upside down.
Your jokes are going downhill too.
I'm built upside down. My nose runs and my feet smell. Yeah, it should be the other way.
That's terrible.
Okay. Anyway, so one definition of a parabola is a set of all points that are equidistant, meaning the same distance from a line called the directrix, and a point called the focus. This nice picture here, this line here is called the directrix, this point here is called the focus. And notice that, that this distance from here to here are the same. So from here to the parabola and from here to this point, that distance is the same. And any point that I pick on that parabola, this distance from here to here, and this distance from here to the focus are going to be the same. Now that's why you see so many, on your house, you guys have like, some of you might have satellite dishes and stuff like that. You know that? Well, the other thing about the focus, if you come straight in here, it's going to bounce off that dish and it's going to hit that point called the focus. So any point that I hit on a parabolic dish is going to bounce off and it's going to go directly to the focus. All right? And so, but this line is called the directrix. It's just some kind of imaginary line that's used to generate the parabola. Okay, so if I want another point on that parabola, like this point, say out here somewhere, the distance from here to here and the distance from here to here are going to be the same if that is a point on the parabola. You see? Okay. So a paraboloid, that's one of those things. Okay, it's a three-dimensional rotation of a parabola. And then, so if I were to take this shape and spin it, right, along the x-axis, then I get a paraboloid, which is like a satellite dish, or the cone to a rocket or something like that would be an example of a parabola. And those have a lot of useful applications in science, I think. Rockets, satellite dishes, and probably satellites, and all that kind of stuff.
Race cars.
Okay, and what?
Race cars.
Race cars, yeah. Yeah, okay. So anyway.
Like the lights, the headlights.
Oh, the headlights. Okay. Sounds good to me. Standard form of a parabola. So this is a little bit different than what we have seen before, okay? If it's a y-squared parabola, this is not really a function because you can't, it's an equation, but it's not really a function because functions, remember, have to pass the vertical line test. But this form of a parabola, it's a sideways parabola. So if it's got a y squared, it's a sideways parabola, and if it's of this form, this is 0, 0. P is the P0 would be the coordinates of the focus, okay? And x equals negative P over here would be the equation of this vertical line, which is the directrix, such that the distance from here to the parabola and the distance from the parabola to the focus is the same. All right? If it's an x squared parabola, those are the kind you are more familiar with, right? And those are like this. And those go on forever and ever. And those have vertices at 0, 0. A focus right here somewhere in the middle, 0, P. And then a directrix down here at y equals negative P. All right? Now, one thing to remember, which we'll talk about a little bit further down on this worksheet, I'll just talk about it now, is if you look down here, if P is greater than, find the equation of hyperbola, graphs of P is greater than 0. See that? Is that what your sheet looks like? Yeah, so I guess so. So if it's a y squared parabola, y squared equals 4px, 4px, then those ones are going to look like to the right if it's positive. That's not a very good graph. To the right if it's positive, and to the left if p is less than negative.
It's supposed to be the shape of the parabola?
Yeah, it's supposed to be a shape of a parabola. Okay, so that's a parabola. One more try. I'll try again.
Beautiful.
Little bit better. Okay? So, and then if p is positive, it's a right side up parabola, and if p is negative, it's an upside down parabola. So, just so you know that, you can get that from these equations, but it's kind of more trickier. All right? Can I move on? Sure you can. Okay. So then find the vertex focus and directrix of each parabola. So looking at this equation, you know the way I would do this is you know that 4p is equal to what? Negative 12. Okay? So that means that p is equal to negative 3. And so to find all these things, you can use the formula, okay? Or you can just draw a picture of it, okay? I know that this is a sideways parabola. I know it's negative, right? And I know it's got a vertex through 0, 0. So I know the vertex is at 0, 0. I know that the focus is at P0. I found P down here. So that means that it's at 1, 2, 3, negative 3, 0. And the directrix is over here 3 units away from the vertex of the parabola. So the directrix, if I were to draw it in, is going down this way. X equals 3. Not very straight line. So this is the directrix. X equals positive 3 because focus is at negative 3. This is the focus at negative 3, 0. And then the parabola itself kind of goes through 0, 0 and goes like this. All right? Okay? Like that. Any questions on that?
So wait, the directrix is that like
It's always, is it always what? Yeah, it's always not inside the parabola.
So you show how you got
So it's the same distance from like
P?
where the focus is.
Because this is 4p, right? So since 4p is negative 12, based on this equation,
Oh,
right?
yeah, okay.
So 4p is negative 12, so p is negative 3. Okay?
Where's the x go?
Where is the x go? The x is a variable, as is
You
the
don't
y,
use the
right?
x to find it.
So x and y's will give you various points on this parabola, right? So for instance, if I want to know when x is 2, what's y, I could do that, right? You would have 2 different values, or negative 2. Okay, then to do this one here, I'm going to divide both sides by 2 first, because it's not in this form, like this. So I get x squared equals 4y, right? Which means that 4p equals 4, so p equals 1. So again, if I were going to draw an xy axis, all right, let's just bring it on. Okay? If I were going to draw an xy axis, so I know that this parabola, again, since it's of this form, it's not of one of these forms, it goes through 0, 0. It says vertex is at 0, 0. Focus is at 0p. So the focus is over here, excuse me, at 0, 1. And then the directrix is over here. The directrix is over here 1 meter away from the vertex of that parabola. So this is going to be the equation of that line is y equals negative 1. And then I could sketch in my parabola, which looks like something like that. Okay? Now, one thing, if P is small, then you have a skinnier parabola. So if this number is very small, then this parabola is skinnier than this one where P, or the absolute value of P, is big, like 3, right? That makes it wider. So a bigger number for P, or a bigger absolute value, makes it wider, and a smaller number makes it skinnier. Okay? We're good with that? Shall we move on? Sure. Yes, sir.
Will there ever be a situation?
So the young man in the audience just asked, scholarly young man, I might add, and a good basketball player at that, just asked, is there ever a case where the vertex is not at 0, 0? And here it is. Now here's a whole bunch of formulas. What I would suggest is, rather than memorize, well, these you should know, okay? But all this stuff, I would do it just by drawing a picture, all right? So so y minus k and 4p x minus h, hk is where the vertex is, okay?
Okay.
And x minus, just like a circle, which we've talked about before. And the parabolas, the ellipses, the hyperbolas, they all work kind of the same form, all right? I stop? Okay, so moving on to a problem like that. It says, find the focus, vertex, directrix, and graph of this parabola. So this one here, is this going to be a right-left parabola, like this way, or is it going to be an up-down parabola? It's going to be a right-left because it's the y is squared, okay? And you know that hk is going to be -1, because this is +1. This is h, that's negative h, and this is k, right? So hk is -1, comma, +3, right? So far, and the way I would do it, this is, it says find the focus, vertex, directrix. I would first kind of try to sketch a graph of it. That's what I always try to do. So if I get it, because I'm more of a visual learner, you know? So if I were going to do this, and I know that the vertex, excuse me, is at -1, 3, so I go back 1 and up 1, 2, 3, and I kind of put a point there. Also, I know that, is this one going to be going right, left, or left? Is it going to open to the left or open to the right?
Open to the right.
Good. Since this number is positive, it's going to open to the right. Okay? And now I can find some specific points. Okay? For instance, for P, I know is equal to 20. So P equals 5. All right? So since I know this opens to the right, and I know that the focus has to be 5 units away from this vertex, since this is a point -1, 3, the focus has to be 5 units to the right of that. So 1, 2, 3, 4, 5, right? And so that means that my focus is over here at 4, 3. You guys understand that? Okay? It's kind of helpful if you draw it. Now the directrix is going to be 5 units to the left of that, right? So if I were to draw a vertical line in here at the directrix, okay? So this is going to be x equals negative what? 6, okay? And again, you could use these equations up here, which you would have gotten the same thing. These equations, the focus, all I did was I took h, go away, so all I did was I added p to h, right, to find the x coordinate of the focus, and I subtracted h, is that what I did? I subtracted directrix x minus h. So I subtracted p. I think you could do the same thing. Subtract p from h. Subtract p from h to get the equation of the directrix. Okay? Or h minus p would give you the h is 4 minus p. Yeah, that works. Would give you this. Or you could just draw a picture of it. Okay? And then, so I think we've done everything they asked us to do, haven't we? Find the focus and graph of this. And then you would want to sketch in a graph. Now,
It's gonna go wider.
yeah, very good. And since p is a big number, this is a fairly wide parabola. So when I sketch it, it's going to be something kind of like that. Now, if I want to find, it's wider even than that. If I want to find some specific points, that's where x is equal to 0. So I could plug in 0 in here, right? And I would get y minus 3 squared equals 0 plus 1 is 1, right? So you get 20. Yes? Did I do that right? 20 times 1. I did. So y is equal to plus or minus the square root of 20 plus 3. I just did some quick math. And the square root of 20 is 4 point something, plus 3 would be about 7 point something. So this point is going to be about 7 point something. Yes, we have one.
But we have a review packet too.
Just the wider,
Okay.
the larger than.
Anyway,
So can you go back to that?
Go back to that. So this point would be 3 plus the square at 0 comma 3 plus the square root of 20. Okay, 0 comma 3 plus the square root of 20. And this point would be 0 comma 3 minus the square root of 20. And so they might ask you to find some specific points. All right? I'm going to do one more. You ready? Sure, yeah. Okay? So this next one, we have to do first. So sometimes, unfortunately, they give you ugly looking things like this. And you have to do that horrible thing called completing the square to get it into the proper form. And since x is the thing that's squared, this is the part that you want to complete the square on. Okay? So who can tell me what I do to complete the square on this? X minus what?
3.
3, thank you. 3, half of 6, which is 3. X minus 3 squared minus 4y plus 5 equals, how much did I add to this when I completed the square? 9. Okay, so since I added 9 on this side, I need to add 9 on that side. You guys see why? Because if I FOIL this out, x minus 3 times x minus 3, right? I get x squared minus 6x plus 9. So when I change this into this, essentially I added this 9. So to keep my equation balanced, I need to add 9 to this side. Okay? Now I want it to be an x squared something parabola. So I'm going to say x minus 3 squared, and I'm going to bring everything else onto the right side. So that becomes 4y, and 9 minus 5 makes what? Plus 4. How convenient, right? And now what I can do, anyone want to guess what I do next? Factor out a 4. 4 times y plus 1. So now, if I want to find all the stuff on this, first of all, I know this is a right side up parabola. I know that its vertex is at 3 comma negative 1. 3 comma negative 1. 1, 2, 3, down 1. I also know that 4p equals 4, so P equals 1, which means that the focus is going to be right there, right? There's that at, what's that? That's 3, 0. And then I know that the directrix is going to be 1 unit south of there, right? So here's the directrix. That's not very good position for it, but it is. So this has the equation y equals -2, because it's 1 unit below the vertex. So then if I were to sketch this one, this is a relatively steep parabola, right? Or this is like a y-squared parabola, so I think it's going to go through that plane and up here and through here. And whoops, that's a really bad parabola. But you get, it doesn't do a little jiggle like that. Okay? Should I do this one? Sure you should. Okay, let's look at this one. A satellite dish, because people always get confused. And I had to what? So I was lying. I know I'm going fast, but that's why you can watch this on YouTube and you can do it again. Okay? A satellite dish is shaped like a parabola of revolution. Its dish is 8 feet across and its opening is 3 feet. This is a simple problem, but people always mess up on this on a test and they go, I don't know how to do this, well, please help me, I don't know. And so I'm helping you right now before the test, all right? So what you want to do with this one is draw a parabola kind of like this where it's centered at the origin. So here's your satellite. Ooh, that's pretty good. I'm pretty impressed with myself. That should say if the dish is 8 feet across at its opening, okay? So from here to here, okay, it's 8 feet across. So here to here is 8 feet. It should be symmetrical around the x-axis, but that's okay. So that's 8 feet from there to there, very dead, okay? And 3 feet deep at its center. So what that means is this point right here is 0, what? 3. Okay? At its opening, 3 feet deep at what position should the receiver be placed? So what they mean is where is the focus? Okay? So the focus is not right here at 0, 3. So what you have to do is you know that since this is 8 feet across, what would the coordinates of this point be right here? And this is right in the middle. What would the 4, 3? Okay. Now this is pretty easy because this is an x squared equals a 4py. There's no shifting of the origin or anything like that. Okay. And now to find 4p, what I do is I take this point and I plug it in for x and y respectively. Okay? So x is 4, so I get 16 equals 4p, and y is 3, right? So I get 16 equals 12p. So p equals 16 divided by 12, right? Which is the same as 4/3. So this, if this is 0, 0, where should I put the focus?
4/3.
At 0, 4/3. So if this is 0, 3, it's like up 1 1/3. So right there is where your receiver should go, 0, 4/3. And so if this is on the top of your house, all the signals are going to come in and bounce off and hit that focus right there. Isn't that cool? See, now you can work for the dish network. You can figure it out. See, all those signals are going to come in and go right to that point. Okay? So that's about it. I think you can figure this one out. It's just like that last one, except the numbers are ugly with completing the square. And there's some homework for you. Okay? Which will be due tomorrow, by the way. Okay. And remember, you heard it here on Mr. Reader's Cutting Edge Math Channel.